Welcome back, mathematicians. In this video, we are going to look at the signs of the 6 trigonometric functions of an angle theta. So let's start with identifying whether the x-coordinate or y-coordinate of a point in each quadrant is positive or negative. And in this case, what we're doing is not including when the terminal side of angle theta is on an axis. That is called a quadrantal angle, so that is not included in this scenario. So in quadrant number 1, what we know is that the value of every x-coordinate will be positive, and the value of every y-coordinate is also positive. In quadrant number 2, what we know is that the x-coordinate will be negative, the y-coordinate is positive. Quadrant 3, what we know is that they are both negative. And in quadrant number 4, what we know is that the x-coordinate is positive and the y-coordinate is negative. Now I'm going to go ahead and rewrite sine, cosine, tangent, cosecant, secant, and cotangent in terms of their ratio with x, y, and r. So in other words, sine is y over r. Cosecant is r over y. Cosine is equal to x over r, and secant is equal to r over x. Finally, tangent is equal to y over x, and cotangent is equal to x over y. So you can see why I grouped these together, because sine and cosecant depend on the sign of r and y. Cosine, secant, x and r, tangent and cotangent, x and y. Now, one thing to quickly note is that the value of r will always be greater than 0, meaning that it will always be positive. It is the distance from the origin to any point on the terminal side. So as a result, the value will always be positive. So let's look at quadrant number 1. And what we know is that for quadrant number 1, for sine and cosecant, because y is positive, r is positive, positive over positive is a positive. So quadrant number 1, cosine and secant, x is positive, r is positive, so positive over positive is equal to a positive ratio. Finally, tangent, same thing, y is positive, x is positive, so positive over positive is a positive ratio. Let's go to quadrant 2, where it gets more interesting, because now we have an x-coordinate that is negative. So for sine and cosecant, we have a y-coordinate that's positive, an r value that is also positive, so the result is a positive ratio. In quadrant 2, cosine and secant, however, x is negative and r is positive. So what we have is a ratio of a positive value and a negative value, and so what we get is a negative ratio. And finally, tangent or cotangent, y is positive, x is negative, so the result is going to be a negative value or negative ratio. Let's go to quadrant number 3, where both x and y coordinates are negative. So for sine, you have a negative y over a positive r, or cosecant, positive r over negative y, and the result is a negative ratio. Let's go to cosine. Cosine, you have a negative value for x, positive value for r. The ratio of those two will be negative. Finally, tangent is a negative value for x and a negative value for y, so negative over negative results in a positive ratio. So now we're going to go to quadrant number 4, where the y-coordinate is negative, but x is positive. So for sine, we have a negative y over positive r, which means the ratio is going to be negative. And then for cosine and secant, our x-coordinate is positive, r is positive, so positive over positive is a positive value. And finally, for tangent, we have a negative y over positive x, or for cotangent, it's going to be positive x over negative y. So the ratio is a positive and a negative, which makes the result a negative value. Let's now go to problem number 1, or the first example, where we are being told if sine of angle theta is less than 0 and cosine of angle theta is greater than 0, name the quadrant in which the angle theta lies. So in other words, what quadrant will the terminal side for angle theta lie? Well, in quadrant, or for the first scenario, and I will use colors to differentiate these, for what we know is that sine of angle theta is less than 0. So sine of angle theta would be less than 0 in quadrants numbers 3 and 4. But we also know that cosine of angle theta is greater than 0, which means it's positive. So cosine is positive in quadrants 1 and quadrant 4. So what you need to do is determine where the overlap occurs. The terminal side can't be in quadrant 1, because then it doesn't satisfy the first criteria, which is that sine of angle theta would equal a negative ratio. It can't be in quadrant number 3 because then it doesn't satisfy the second criteria, which is that cosine of angle theta is going to be a positive ratio. It has to be in quadrant number 4. So to draw this out, what we would know is that our initial side is on the positive x-axis and terminal side would be in quadrant number 4. Let's now look at an example where we are given that tangent of angle theta is equal to -3 and cosine of angle theta is less than 0, meaning it is negative. We are going to find each of the remaining 5 trigonometric functions, so we need to find the exact value of each of these. Now let's start with the fact that we're given some information, and let's go ahead and draw a picture that represents this information. What we know is that the vertex will be on the origin, initial side will be on the positive x-axis. But we don't know where the terminal side lies, and that is the first thing we need to determine. Now, tangent is equal to a negative ratio, and tangent is negative in 2 quadrants. That would be quadrants numbers 2 and 4. Cosine is also negative, and cosine results in a negative ratio when the terminal side is in quadrants numbers 2 and 3. So what we now need to do is look for the overlap. Well, the overlap occurs in quadrant number 2, so that's where we know our terminal side lies. Now, let's go ahead and identify a point on the terminal side. We need to find the x and y coordinate of that point. We also need to find the distance from the origin to that point, which we know is a value of r. So let's start with the fact that we're given tangent of angle theta is equal to -3. Which we know is equal to -3 over 1. We also know the tangent of any angle theta is equal to y over x. So we know the value of y and x now. Now be careful where you assign that negative. You probably want to, by default, assign it with y, but we know since we're in quadrant number 2 that the y coordinate is positive. So that's going to be a +3 for my y coordinate and a -1. You can assign that negative to either the numerator or denominator, whichever one will match the information that you need. So now we need to find the value of r. To do that, we're going to use the Pythagorean theorem. So r is equal to the square root of x squared plus y squared. So r is equal to the square root of -1 quantity squared. Again, use parentheses anytime you're doing substitution. And then that's plus y squared, which is 3 squared. That means r is equal to the square root of 1 plus 9, which means r is equal to the square root of 10. So in this case, again, r is a positive value, but it doesn't necessarily mean it's always going to be an integer. So now that we have r, we can go ahead and write our 5 remaining trigonometric functions in terms of x, y, and r. So what we know is that cosine of angle theta is equal to x over r, which in this case is going to be -1 over square root of 10. Now, if you are required to rationalize the denominator, that means you should multiply the numerator and denominator by square root of 10. This would result in negative square root of 10 over 10. The next is going to be sine. So sine of angle theta is equal to y over r, which in this case is going to be 3 over the square root of 10. Again, if you need to rationalize the denominator, multiply the numerator and denominator by the square root of 10. This will give you 3 square root of 10 over 10. Next, I'm going to do the 3 reciprocal identities. So I'll start with secant. Now, secant of angle theta, you can really do the reciprocal of any version of cosine of angle theta. So I could do the negative square root of 10 over 10, but I'm going to instead choose to do the reciprocal of this ratio, which is equivalent to negative square root of 10 over 10. And so what I get is square root of 10 over 1, and it's negative. So this is just negative square root of 10. Cosecant of angle theta, again, I can pick any variation to the ratio as long as it's equivalent. And what I'm going to pick is this version right here, which is a little easier because I don't need to rationalize the denominator. So what I get for this is cosecant of angle theta is equal to square root of 10 over 3. And then the last one is cotangent. And cotangent of angle theta is going to be the reciprocal of tangent. We know tangent is negative 3 over 1. So cotangent of angle theta is going to be negative 1/3. All right, guys, good luck.